Okay, this is Chapter 8, Section 3, Perimeter and Area. Make sure you understand that the reason, it says if you were to walk around the outside edge of a volleyball court, how far would you walk? If you had to place floor tiles that each measured 1 foot by 1 foot on a basketball court, how many wood tiles would you need? In this section, we will study the geometric concepts of perimeter, which is the distance around, area, which is the distance inside, or area is the amount of space inside. All right, so the definition of perimeter of a two-dimensional figure is the sum of the lengths of the sides of the figure. Area, definition is the measure of the region within the boundaries of the figure. So we come over here, we have a bunch of formulas. Perimeter of a rectangle. A perimeter equals 2 times length times width, 2 times width, because in a rectangle you have 2 lengths and 2 widths. So, it's a distance around. For area of a rectangle, it's length times width. That will give us, if we look at a rectangle, if we go the length times the width, we get the distance and we get the area inside. Area of a square is sides squared. In other words, it's the same as a rectangle, length times width, but the two sides are the same, so it's S squared. Parallelogram is base times height if we want the area. Area of a trapezoid is 1/2 times the height times the two bases added together, the sum of the two bases. Okay? And here on page 469 are the formulas that are written in one space. There you have the area of a triangle, the perimeter of a triangle, just adding all three sides. There you have a square, the perimeter of a square, area of a square, perimeter of a rectangle, area of a rectangle. Here you have, which is on page 470, here you have the perimeter of a parallelogram, area of a parallelogram. You have the perimeter of a trapezoid, area of a trapezoid. So, looking at this problem here, it says, Malik wishes to install mahogany hardwood flooring in his home office. The rectangular office floor measures 18.5 feet by 12.5 feet. Flooring is solid, sold in cartons that cost $220, and each carton contains 20 square feet of flooring. Only whole cartons of flooring can be purchased. Determine the area of the floor. So the first thing we're going to do is determine the area of the floor. Is we're going to take 18.5 times 12.5. We get 231.25 feet. Determine the number of cartons of flooring he'll need. So now we're going to take this and divide by 20. We find out we need 11, basically 11 and a half cartons, but they don't sell half cartons, so we're going to have to go with 12. And it says determine the cost of the flooring purchase. So now we're going to take our 12 cartons and multiply times $220, and it's going to cost us $2,640. Pythagorean theorem is dealing with only right triangles. Remember that your longest side, which is labeled C, is always opposite the right angle. And these are called adjacent sides. Okay? The adjacent sides are what make up the right angle. The Pythagorean theorem is taking side A and squaring it, plus side B and squaring it, and it will equal the longest side, side C squared. Look at this problem. It says the moat surrounding a castle is 18 feet wide, and the wall by the moat of the castle is 24 feet high. If an invading army wishes to use a ladder to cross the moat and reach the top of the wall, how long must the ladder be? So what we know is that it's 24 feet high, and if we're going to set the ladder on dry land and try to get across the moat, it's got to be 18 feet. So we can use 24 squared, 18 feet squared, which is what we have here. Add those together, take the square root, and we get 30 feet. So the ladder has to be 30 feet in order for us to be able to get across the moat. Then we have circumference and area of a circle. All right, circumference is the same thing as perimeter, only it's a circle, so it's a curved motion. So circumference gives us the distance around the circle. And that is 2 times pi times r. Remember, pi is 3.14. Area of a circle is pi r squared, so it's the radius squared. And make sure you understand that r represents radius. It's half the distance from the center to the outside edge. Diameter is the distance across each edge going through the center only. And this one here says comparing pizzas. It says Jana wishes to order a large cheese pizza. She can choose among the 3 pizzas parlors in town: Antonio's, Steve's, and Dorsey's. Antonio's large cheese pizza is round, 16-inch diameter, and $15. Steve's large pizza is round, 14 inches, and $12. Dorsey's large pizza is 12 inches by 12, but it's a square pizza and sells for $10. All 3 pizzas have the same thickness. To get the most of her money, from which pizza parlor should she order? All right, so what we do is find the area involved. So because Antonio's a round pizza, the area is pi r squared, which gives us 201 because we go 64 times that. Steve's pizza is, we go 7 because it's half. Remember, the pizza is 16, the diameter 16, diameter 14, so we get this. And in terms of the area with Dorsey's pizza, it's square, so we just do 12 squared, 144. Now we're going to take this area and divide into the price. So 201 square inches goes into $15. We get 7 cents, almost 7.5 cents. This divides into here, we get 7 cents and 8. Here we get just a little less than 7 cents. So it looks like Dorsey's pizza is the best buy because it's the cheapest. In terms of this problem here, it says determine the shaded area of the figure below. All right, so what we're going to do is we can first of all figure out the area of this trapezoid, figure out the area of the circle, and then subtract the area of the circle from the area of the trapezoid. So here's how we do this. There's the area of the trapezoid, right here, just using the formula. Here's the area of the circle. We take the area of the circle, the area of trapezoid, and subtract the area of the circle from it, so we find out the shaded region is 65.73. If we talk about square unit conversions, then basically what happens here is we want to convert 1 foot squared to square inches. We got to go each 12 by 12, so it's 144. We want to convert 37 square feet to square inches. And again, we got to go in terms of 37. We got to figure out how many square feet are in 37. So we got 144. 37 times 144, because we're going to use this value up above because we know 1 square foot has a 144 square inches. So we're just going to take 144 square inches and multiply times 37 square feet. And then the last one says convert 432 square inches to square feet. Well, we're going to do the opposite. We're going to take that 432 square inches, divide by 144 square inches. We find out it's 3 square feet.